All right, here's a couple of questions involving radicals. So the first question, equilateral triangle, all sides the same, shown below. Find an expression for its height in terms of A. So the height. So I could, let's see, I was thinking area. Well, but area is B. I do know, though, that for a triangle, it's A squared plus B squared equals C squared. And this is the longest side, so it would be on the side by itself. So it'd be A squared is equal to, uh, so longest side is equal to the other two sides squared the sum of them. So it'd be A over 2 squared plus H squared. Okay, so for this part here, that's the same as A squared over 4 plus H squared is equal to A squared. And then I'd move this term to the other side, so it'd be A squared minus A squared over 4 is equal to H squared. Looking a little ugly. I could get a common denominator of 4. So if I put a 4 here, I got to put a 4 there. So it'd be 3A squared over 4 is equal to H squared. Hopefully there's not any magic there happening yet. And then to find H, I'd need to square root both sides. So it'd be the square root of 3A squared over 4. Now, I can't take the square root of 3, so it stays, but I can take the square root of A squared, that's just an A, and I can take the square root of 4, which is 2. So that's probably what I'd come up with for that expression. Then they say find an expression of its area in terms of A. All right, so area. Area of any triangle is a half times the base times the height. So area is equal to a half. The base, that whole thing would just be A times the height is just H. Oh, but it says in terms of A, so I can't have any H's in it. But I did just figure out that H was this, so I could plug that in there. Root 3A over 2. And then since this is all multiplied, the 2 times a half, I think that gives you 1. Oh, no. No, that wouldn't be right. If that was a 2 there, it would cancel, but it's a half, it won't. So a half and another half would be a quarter. A root 3. Oh, there's another A. A equals a quarter root 3, and then there's A times A, so A squared. They might write it like this, root 3 over 4 A squared. That's probably what I'd come up with. So that's an equilateral triangle one. That's a nasty question. Like that one. Okay, another one. A diagonal of a square. Here's a square. Diagonal has a length of 8 root 2. Find the length of a side of the square. Okay, well, this side is x, and since it's a square, that side would be x. I can use Pythagoras again. So 8 root 2 squared is equal to x squared plus x squared. That's our formula, Pythagoras. And c is always the longest side. That'd be this one. Okay, 8 root 2 squared would be 64 times 2. 8 root 2 times 8 root 2. 8 times 8, yeah, 64. Root 2 times root 2 is root of 4, which is 2. So 64 times 2, I was right, is equal to 2x squared. So this would be 128 equals 2x squared. Divide both sides by 2. And then square root both sides. So I'd get a plus or minus 8. But since it's a distance, I'm probably saying it's not the 8. So each side here is going to be 8. All right, another question, and this deals with fractional exponents. So here I've got x to the 2/3, y 5, 6, etc. So I want to combine these guys. So if I'm dividing common bases, the rule says subtract their exponents. So it'd be x to the 2/3 minus a negative 1/3. Same thing with the y's, y to the 5/6 minus 1/2. So this would be x to the 2/3 plus 1/3. Well, that's 3/3, so that's 1. So it's just x by itself. And then this is y to the 5/6 common denominator. That'll have to be a 3/6. 5/6 minus 3/6 is 2/6. So y to the 2/6. And I can simplify that to y to the 1/3. Okay, hopefully that helps you with those kind of questions. And I guess I could rewrite this as x times the cube root of y. They might want the radicals back in the end. Okay, hopefully that helps you with those ones.